So this time, guys, I want us to consider how are we supposed to sketch how are we supposed to determine the equation of a certain function considering a parabola. We are going to focus on a parabola, which is our quadratic graph. So on determining or finding of these equations, they were given, find the equations of the following sketch graph. So they were given the sketch on number 16, 17. So these are the sketches that we are given of a parabola, the normal part that we are used to on a parabola. So whenever you are to consider, you must work with the previous condition that you had when you were to draw. Remember, when you're to sketch this quadratic function, you must consider also that part again that, okay, if I'm given the function, let's say we are given y is equal to ax squared plus bx plus c. We know that on a normal format of this, the a, when it is greater than a 0 like that, when it's a positive, we're going to have a smiley shape like this. When it is less than a 0, we're going to have a Z shape like this. We talked about that. Then also, you're going to consider the part of the y-intercept and the x-intercept, which are the x-intercepts or the roots. We know these are the x values where the graph cuts the what? The x-axis, where the graph cuts the x-axis, all right, the x-axis. We also do understand about the y-intercept also. Remember your y-intercept, the y-intercept, we do understand this is a condition where the graph cuts the y-axis, just like the part of the x-axis. So knowing this and the turning point provided that is given, it can be an advantage for us to understand the concept of our graphs, the formats. What were you having before? If I'm to consider this function, I'm given this function, as we can see. Let's see what we have. It is passing through -4, and also there we are given a +4. So these are the values where the function is crossing the x-axis at -4 and at also a +4. These are the x-intercepts, the solutions that you are given. Consider to say that you have got something of this nature. You were definitely going to have a turning point, a graph passing the y-axis, the y-intercept there, then also have a turning point like that. But if we are to consider on this graph, we do not have that condition. If we check the point 16, that -16 there, it's a little bit that 15, then in between the 15 is here, then in between there, that's a -16 that we are given at this point here. So this one, that's a -16. Is the y-intercept this point? It is the y-intercept. It is also a turning point and also a turning point. What type of a function was it, guys? Where we had the y-intercept being the turning point also, where we have got different x values on our solution. That was the type of a function, if you still remember, where we were having our quadratic graph. That was the type of function of y is equal to something like this, ax squared. Then we are going to have a plus or a minus c in that case. Remember, this a can be positive or negative like this part. That was the part that we had before. So meaning to say, as we are to consider this graph, we are supposed to expect to have this condition. We expect to have this condition. All right. So let's say I do not know what's going to happen in terms of the condition. Am I limited? No, you are not limited. This is what you're going to do. You are going to have, if there are solutions, when given solutions, solutions, which are the roots, when given the roots or solutions or the x-intercept that you're given, you are going to have your equation express equation or express that equation. I'm going to write in short, guys, in the form in the form. All right, so we're going to have our equation in the form y is equal to a into x minus x1, where x1 is the first solution that you are having into x minus x2. So this is going to be the format that you are going to use to determine your equation, provided that you are given the roots of this. So there are different x is equal to this, y, not like here where we just have 1 point. There I'm going to explain about that type. But if you do understand like the previous case, also it's important that you note how your equation is going to be at the end. So this here, where x1 and x2 are the solutions, or the roots of the function. So this is where remember, the x values is where this graph cuts the x-axis. Where is this graph going to cut the x-axis? So the first one, let's consider question 16. We're going to determine the equation there using this concept because we have got different solutions there. So we are going to have y is equal to a according to the format that you're given. So it's a into x minus x1 into x minus x2, where these are the solutions. So considering the first solution that you're given, in this case, it's going to be a into x minus x1. So let's take, there's a -4. It's a solution there. So it's supposed to be x minus minus 4. So minus minus, that's what? A plus. So it's going to be x plus 4. We move on to the second solution, x minus x2. So it's x minus our x2 there. That's a 4. So it's just x minus 4. Like that. So this is what you're given. So as we can see, in the simplification, if I was to simplify, depending with the understanding, now it's you guys, your expansion of brackets, you're supposed to expand this, but also by realizing that this is a difference of two squares, there's a plus, a minus, same brackets. So it was taken from a squared minus b squared, which is equal to a minus b into a plus b. So that's a and a squared, which is going to be x squared, the b going to be b squared. So 4 and 4 here, that will be 4 squared, which is 16. So this is what we have. And we can clearly see that it's not complete, this equation, because we are not having the a. A is not known. We do not know the value of a. So this is it. We substituted the x1 and x2, which were the roots of the function. So this is what you're going to do to determine the value of a. You substitute any point that is on any given point on the graph. Any given point on the graph. Any given point besides the solution. So you're going to substitute any given point. So you choose any given point that you're going to work with besides what? The solutions, besides the roots. Remember, the roots are the ones that you used here. So when you substitute that, you're simply neutralizing your equation. So there's nothing that you're going to obtain from there. So in this case, we can consider the turning point, since we are given the turning point. So like I said, guys, here these boxes are not clear. It's like -3, -6, -9, -12, -15, -18. So the -16 is the one that is in between, the one they are trying to indicate there. So it's a point that you're given, which is the turning point that you can use. Remember, the turning point that you're given, it's on a condition where x is equal to 0 and the y value there is what? -16. So we can use any point. In this case, we can use 0, -16, which is our turning point, where x is equal to 0, y is equal to what? Y is equal to -16. So we can substitute -16 in place of y is equal to a into x. X is supposed to be what there? As 0. So that's 0 squared minus 16. So let's solve for a. As you can see, we formed an equation. Solve for a, an equation. So -16, 0 minus 16. That's -16 times a divided by -16 here. All right, guys, use your calculator. Okay, just use your calculator here. Gonna obtain -16. So divide by -16. both sides, that will be the value of A was going to be a 1. All right, so as you can see in this equation, we have determined everything that is needed, the value of A and so on. So therefore, we are going to have Y is equal to, in place of A, we are going to substitute a 1. So that's 1 into x squared minus 16, which is simply Y is equal to x squared minus 16. If you multiply by 1, it is going to remain as it is. And that is the formula that I was talking about. Y is equal to ax squared plus or minus c. So if you know these formats, also it can help to say, okay, at the end, are you having exactly what you're supposed to have? So this is different. Okay, we do not have that condition. All right, so I'm going to leave number 17. Let's move on to 16 so that we conclude on this part where we are given this condition. So I'm going to talk of number 18, then we're going to go to 17. So if you check on number 18, it's still the same thing, same concept. There is just a single turning point. The turning point is the y-intercept. So you know your format, how it is going to be like. So if you know that format or you do not know the format, guys, it's not a problem. What you just need is that the format y is equal to, because there are different solutions there. There are two solutions there and there. So you're going to consider this as y is equal to a into x minus x1 into x minus x2. Having this is going to be easier to work with. So y is equal to a into x1, the first solution that you're given on this negative side, the number indicated there, that's a minus 5. So it's x minus minus 5 like this. Minus minus, that's a plus. All right. Then we move on to the other part. X minus x2, which is our solution, the number indicated there, which is a 5. That's our solution. So by just clearly expanding, we can see, go back again to the difference of two squares concept, where we have got x squared minus 25 by expanding the brackets or realizing our difference of two squares. But this is not enough because we do not have the a. So like I said, to determine now the value of a, you are going to consider any point that is clearly given on the graph. We can consider the turning point. We have that point which is corresponding at what? At 25 in this case. At this point, 25 as our turning point or the y-intercept. It's up to you. But what we do know is that it's along the y-axis where x is equal to 0. That's a point. X is equal to 0 and y there is 25. So there, any point, we're going to use 0, 25. So I do not know, you call this the y-intercept or you call it the turning point. It's one and the same thing. It's a turning point. It's also the y-intercept. It's also the y-intercept according to this graph. Remember on our introduction. So that's a point that we have where we've got the x value and the y value. So by substituting the y value, which is 25, and x being as 0, that will be 0 squared minus 25. So on your calculator, that is going to be a negative 25 times a, which is negative 25a. So let's find the value of a by dividing by negative 25 both sides. That's our a is going to be a negative 1. So therefore, our function can be written now as y is equal to, where there's a, when I have negative 1 into x squared minus 25. So let's expand. Negative times x squared, negative x squared, negative times negative here, that will be a positive 25. All right, so that's a positive 25 in that case. So that's our equation. That's our function. That's our clearly function that we're given. So it will depend condition that you're given. All right, let's consider these two, how they are. All right, let's start with this one that you're given. Remember, I explained also about this type of function, which will just pass through the origin, then it retains back. It just passes through the origin, then it's returning back. This is the format of y is equal to ax squared. If you still remember the format of y is equal to ax squared, where it just passes through the origin, then goes. It's just through the origin. It's not going to even cross that. There is no x-intercept to say there's x here, x, there are no x-intercept that you can consider. So you can't even use that because we're not going to have anything. Y is equal to a into x minus x1 into x minus x2. This is not going to work because we do not have like x1 and x2. Just a single point considered. So the question is, how am I going to determine, since I do know the format, that is, this is the format. In this case, you substitute any clear corresponding point. What you just need is to find A. So by having X and Y, I can determine the value of A. So you are supposed to substitute any point. So you're supposed to look for any point which lies on this function, which lies on y is equal to ax, like the function of f of x that you're given, which lies on that part. All right. Let's see. There is a point, okay, the 0, 0, you can't use that because when x is 0, y is 0, so there's nothing that you're going to have. Let's move on. At 1, is it clear? No, it's not clear. Look, guys, 1, do you know the, do not, guys, hustle when the points are clear. There is a 2 here corresponding direct to 1. The 2 to 1. But remember, a point, you must state x followed by y. So x is what? X is 2. So there's a point 2 and y is equal to what? Y is equal to 1. That's a point. You move on. 3 is not corresponding to a clear value. Look, the value is in. We do not like where exactly that value is. The 4 is not also clear. But if you check on this other side, the -1 is not also clear. This other side here, guys, the way they are drawing also these guys, is not clear. It was supposed to be a -2 there corresponding to 1. But look now, what they're doing. But under exam condition, they will give you a point so that you do not struggle like that. They will give you a point. I'm gonna talk about that where we are given such condition. So that's our x and y. We can substitute that. Because by knowing x and y, guys, we can determine our value of a. Y is equal to 1 when x is equal to what? When this x is a 2. So that's 2 squared. So 1 is equal to 2 squared. That's 4. 4 times a, which is a. So divide by 4, divide by 4. A is equal to what? A is equal to 1 over 4. So by knowing that a is 1 over 4, therefore our equation is y is equal to, in place of a, we are going to have 1 over 4x squared. Knowing the format is very, very important. Very, very important. Knowing your format. All right. What about number 19? Which type of a graph are we considering here? If you still remember, we had the last from our parabola, with the last part, we had something like this. So guys, make sure that you watch those videos if you've not watched like how to draw that, because it's from there. Remember when you're drawing the graphs of y is equal to the square root of x, where this can be ax. When a is a positive, if a is greater than 0, that is a positive, we are going to have our shape this way. Okay, when a is a positive. If a is negative, we are going to have our graph this side. We are going to have our graph this side. When this is a negative, like y is equal to square root of negative ax, when y is equal to a positive square root of positive. So that's the part that we do understand. So this one, look where it is. It's on the positive side. And in this case, we are not given values. We are not given values like to say x is equal to this, y is equal to this. So what we just know is the format. So we're going to write this as y is equal to the square root of, because of the side that we are seeing. So it's the square root of ax. Y is equal to the square root of ax. But if you want, you can also write this in terms of what? In terms of x. If you are writing it in terms of x, it means in your own, you will be having this as x is equal to ay squared, where we do not know this a is going to be a fraction. Is it going to be like this? We do not know how it's going to be like. So if you write it this way, what you simply do is to square. All right, this is our answer, guys. We are done here. But I'm saying you can also write it this way, like y is equal to the square root of ax. You just square here, you square here. So y squared is equal to ax. Remember, to square is to remove the square root. You can write in terms of x, divide by a, divided by a. So meaning saying this one is going to have a fraction to a given. From what we are given, it's going to have a fraction like. But even if you write it like having x is equal to a y squared, it's not, because this is the format. So it's not going to even have an effect. Or you can have it y as y is equal to the square root of ax like this. It's still one and the same thing. Remember, that was our presentation that we are given. So you need to know from how you were sketching the graphs. How you were sketching the graphs. That is, you need to know from there. The idea that you had before on sketching is the same idea that you use on drawing. So we shall have, on determining the equation. So we shall try to see, as we move on, try to have more questions from our question papers and see how do they ask these typical questions. But for now, that's it, guys. From Mason African Motives, till we meet again.